Hi students, in this video we are going to learn about complex plane or organ plane. Let x dash o x and y o y dash be the mutually perpendicular lines known as the x-axis and y-axis respectively. The complex number x plus iy corresponds to the ordered pair x comma y and it can be represented by the point P x comma y in the xy plane. The xy plane is known as the complex plane or organ plane. X-axis is called the real axis and y-axis is called the imaginary axis. You can understand what they say in this paragraph based on the example. Note that every number on the x-axis is a real number. Each on the y-axis is the imaginary number. The complex number represented geometrically in the above diagram are. I'll explain you what it is now. We know that x dash o x and y dash o x be the mutually perpendicular lines means the x dash o x is known as x-axis and y o dash is known as y-axis. If we take a complex number x comma y, you know that x forms the real part of complex number, y forms the imaginary part of complex number. That can be written in the form of x comma y, right? It can be written in the ordered pair. Real part of imaginary number is located in the first place and the imaginary part is located as the second element. It should be written in the same order. That's why it's mentioned as ordered pair. When we have two numbers in the ordered pair, it can be placed on the xy plane. Here this x comma y represents the real part and imaginary part of a complex number. Hence the xy plane which contains the complex number as ordered pair is known as complex plane or organ plane, and x is called as real axis because on the x-axis you know that y coordinate value is 0. In the complex number, y coordinate represents imaginary part. When the imaginary part is 0, only real part exists means we already learnt that it is a purely real complex number. It must be placed on x-axis only. That's why x-axis is called as real axis because it contains only purely real imaginary numbers. And then if you observe the imaginary axis, any point on the y-axis will have 0 as x coordinate and some number as y coordinate. Hence x is 0 means here real part is 0. When real part is 0, only imaginary part is exists means the complex number is called purely imaginary complex number. Hence y-axis contains only purely imaginary complex number. That's why y-axis is called imaginary axis. I hope you understand the basic information now. And based on this we can say that the point A contains coordinates of point A is 3, 5. It means that it represents the complex number 3 plus I 5. In case if you consider this number, this point D whose coordinates are 2, minus 4, it corresponds to a complex number 2 minus 4i. If you consider this point C whose coordinates are minus 5, minus 3, it corresponds to a complex number minus 5 minus 3i. And if you take this point E whose coordinates are 6, 0, then it represents a complex number 6 plus 0i. It means that the imaginary part of the complex number is 0. Similarly, if you consider this point F whose coordinates are minus 3, 0, then it corresponds to a complex number minus 3 plus 0i whose imaginary part is 0. Hence the x-axis contains only purely real complex number, y-axis contains purely imaginary complex number. That is the reason x-axis is called real axis, y-axis called imaginary axis. I hope you understand how a complex number can be placed geometrically on xy plane as a point. Now we move on to next concept, polar form of a complex number. Actually we know that complex number normally takes the form of z is equal to x plus iy. The same complex number can be written in the form of trigonometry, like using sine theta, cos theta, it can be represented. The same complex number can be represented in other form as well. That form, actually this form, is known as polar form of a complex number. We will now learn how to write a given complex number in the polar form. What does it mean? What are the parameters involved in the polar form of the complex number? Now we need to consider the complex number z, which is equal to x plus iy. We know that it can be represented on the plane, on the xy plane, as p x comma y. X talks about real part of complex number, y is the imaginary part of complex number. It can be represented like this on the complex plane. You know that it makes, if you join this point with the origin, it forms a line segment. It makes angle theta with positive direction of x-axis. Now what we need to do is, if we draw a perpendicular line segment from the point P, actually this should be written as point P because it is mentioned P here. So the point P, whose coordinates are x comma y, from the point P I just drawing the perpendicular line to x-axis, and we are joining origin with point P. Now if you observe it, it forms a right angle triangle. So what we can do is, we can find this length as well as this length. For example, how the distance from y-axis to the point gives us x coordinate value, and the distance from x-axis to the point gives y coordinate value. Right now we got the length of, let us say this point is, the meeting point is A. If you observe the triangle OPA, OA length is equal to x units, PA length is equal to y units. Now it is a right triangle. Using Pythagoras theorem, we can find out the distance of OP. It can be used, we can apply Pythagoras theorem also to find out it. Otherwise, we know the coordinates of this endpoint and coordinates of the endpoints. So using distance formula between 2 points, we can say that root over of x2 minus x1 whole square plus y2 minus y1 whole square. Hence the formula is here root over of x square plus y square, distance from origin to the point. We already learnt that distance from origin to the point is denoted as modulus of that point, modulus of z. Modulus of z means it is the distance from origin to the point. Hence modulus of z can be written as square root of x square plus y square. That is what is given here. They represent modulus z as or small r means, here we are talking about modulus z. Modulus z means square root of x square plus y square, right? So now we calculated modulus, modulus of the point P from the origin. Now we need to find out the angle theta. Now in order to find out the theta, what we can do is, since we already know the opposite side to the angle theta and adjacent side, we can use the formula tan theta is equal to modulus of y by x, because opposite divided by adjacent, which gives tan theta. Opposite value is y, adjacent is x, hence tan theta is equal to modulus of y by x. We can calculate theta by transferring tan inverse to the opposite side. When we solve problems, you will come to know how to find out this theta is equal to tan inverse of y. Now you check it. Now if you want to calculate x coordinate value, now I am going to write this x coordinate value, y coordinate value using modulus of z and theta, because in polar form we will write the given complex number in modulus form. Here r is there, r means modulus z, and theta is this angle. Hence in order to convert a given complex number into this polar form, we need r means nothing but the modulus, and we need theta. That is what we calculated. Now we are going to write how this form comes, how this form has been derived from z is equal to x plus iy. Now I am going to find the coordinate, x coordinate value of this point using the angle theta and modulus z. Now if you observe it, we need x, right? We want to find out the value of x in terms of theta and modulus z. So what we can do is we can calculate cos theta. If you observe it in the right triangle, cos theta means adjacent divided by hypotenuse. Here adjacent is x and divided by hypotenuse. Our hypotenuse is nothing but modulus of z. Modulus of z is denoted as r in this polar form, so I am writing like this. So from which we can calculate x value by cross multiplying this r. So x is equal to r into cos theta. Similarly, if you calculate sin theta, we can find out the y coordinate value. Sin theta means opposite divided by hypotenuse. Opposite value is y, divided by hypotenuse is modulus of z. Here modulus of z is denoted as r, hence it is denoted as r. So we can write y is equal to r sin theta. Hence in place of x we can substitute r cos theta, in place of y we can substitute r sin theta. Hence in this form, in place of x we can substitute r cos theta, in place of y we can substitute r sin theta, and r can be taken as common, so that we get r times of cos theta plus I sin theta. So in place of x just we substituted r cos theta, in place of y we are substituting r sin theta, and r is taken as common, so we are getting the corresponding value of the standard form to this polar form. Z is equal to r into cos theta plus I sin theta. In this way we can find out, we can write the polar form of a complex number. To write the polar form of a complex number, we need to find out the modulus of z, that is denoted as r, and then theta can be calculating using this formula. Tan theta is equal to y modulus of y divided by z. This can be written as this theta. Tan theta is, you know that modulus of y divided by x. Y is nothing but our imaginary part of z divided by, and x is our real part of z. So when a complex number is given in the standard form, we can find out tan theta using this formula, and we know how to calculate modulus of z. So using which we can write this polar form. I hope you understand this. Now, and one more information is the value here, the theta is called the argument or amplitude of z, which is written as argument argz or ampz. The value of theta is such that which always lies between minus pi. Actually the theta lies between minus pi and plus pi. It should be written as minus pi less than theta less than or equal to pi is called principal argument of z. When you learn about trigonometry, you will get clear idea about this, but just now you come to know that the theta value lies between minus pi and plus 5. I hope you understand about polar form of a complex number and the complex plane or organ plane. In the next video we will solve problems related to polar form of a complex number and some more information about polar form. Thank you students. Thanks for your cooperation.